Good morning, students. Today we are going to discuss about Deuteron problem. But before going to Deuteron problem, we have to understand some basics that is related to nuclear physics. So, very basic things we will discuss in this lecture video. From primary class itself, you have studied about atom. What is the structure of an atom? Right. To understand the structure of an atom, different models are proposed. As you know, the first proposed model was Thomson's model. So, what this model explains about the structure of the atom. So, according to Thomson model, atom consists of positively charged particle and negatively charged particles. These positively charged particles are distributed in a sphere of radius of order of 10 to the power minus 10 meter. So these positively charged particles are distributed uniformly in this sphere. Remember, order is in this 10 to the power minus 10 meter. And negatively charged particles, electrons are embedded in definite places, just like how the plums are embedded in pudding. Therefore, this Thomson model, also referred to as a plum pudding model. According to this model, these electrons are not at rest. They are oscillating about its mean position. But this model is not accepted. It is because when you analyze the spectra of different elements, what we are observing is different colors are produced. Why the different colors are observing in a spectra? Because these electrons are oscillating with the same frequency. Therefore, if you supply the energy, all the electrons should excited to same energy level. During the de-excitation, all the electrons should radiate light of a definite frequency. But we are observing different colors. Why this is? Then later Rutherford performed an experiment, that is alpha scattering experiments. The results of alpha scattering experiment also not able to explain using this Thomson's model. Therefore, Thomson model was discarded. Next, let us see what is Rutherford model. Before that, let us recall the Rutherford model. Okay. So let us recall the alpha scattering experiment. A very thin gold foil is used by Rutherford, on which alpha particles are made to incident on it. Then Rutherford analyzed the scattered alpha particles. He observed some alpha particles passes without any deviation. Maximum number of alpha particles are scattered with small angles, and few of them are scattered with the large angles, some of them rebound back. See, the question is why these alpha particles are get scattered at different angles. So, to explain this, Rutherford proposed the model according to which an atom consists of central positively charged nucleus around which electrons are revolving in circular orbit. But here, when you consider the mass of the electron with respect to mass of the nucleus, mass of the electron is negligibly small in comparison with mass of the nucleus. Therefore, we can consider that the almost entire mass of the atom is concentrated in the nucleus. So, as you know, when you consider the mass of the electron and mass of the proton, this is mass of the proton is 1836 times mass of the electron. Just you can see the mass of the proton is how much large compared to mass of the electron. So, here from this experiment, what he concluded is an atom consists of large empty space. Why? Because maximum number of alpha particles passes without any deviation. But as the alpha particles approach close to the nucleus, they get scattered because alpha particle is positively charged. Nucleus is also positively charged. When they come very close to the nucleus, they get scattered with large angle. If there is a head-on collision with respect to nucleus, alpha particle bounces back. See, this is using this, we are able to explain the experimental observations of alpha scattering experiment. But this theory is also not accepted because according to electrodynamics theory, every accelerating particle radiates energy to the atmosphere. Therefore, what happens? This is the nucleus around which electron is revolving in circular orbit. That means electron is continuously changing its direction. It is continuously changing its direction means its velocity is variable velocity. It means that electron moves under acceleration. So therefore, electron is an accelerating particle when it is revolving round the nucleus. That means after the completion of one revolution, what happens? According to the theory, it radiates the energy. Because of that, electron loses its energy, and because of less energy, it started to revolve in smaller orbit. Same thing, as time changes, it will roll with the smaller and smaller orbit and finally falls into the nucleus. That means the stability of the atom could not be explained using this Rutherford model. In order to, so this model is also discard it. So, in order to overcome the difficulties present in this model, Bohr proposed the theory that is nothing but Bohr model. Bohr's model. So, according to Bohr's model, just a correction to Rutherford model, according to Bohr, atom consists of central positively charged nucleus around which electrons are revolving in definite orbits where there is no radiation of energy takes place. Such orbits are referred to as stationary orbit. Stationary orbit. So, stationary orbits are the orbits in which electrons do not radiate energy when it is revolving around the nucleus. So, next point is the energy of the electrons is quantized. Right? It is quantized. So, if you consider this is one orbit, this is the second orbit, right? If the electron is get excited from one orbit E1, here energy, another orbit E2, then if you supply an energy is equal to E2 minus E1, it get excited. So, during the de-excitation, it emit the light. This is equal to h nu. H nu is equal to E2 minus E1. So, this Bohr's model is applicable only for hydrogen atom or hydrogen-like atoms. So, what is a hydrogen-like atom? Hydrogen-like atoms are those atoms in which outermost orbit contain one electron. Okay. So, therefore, the Bohr's theory is also not so much success. And moreover, complex spectra could not be explained using this theory. So, from all these, the Bohr's model is discarded. So, in order to overcome the difficulties, right, here Sommerfeld made the correction. So, that is nothing but Sommerfeld model. According to this model, electrons need not revolve around the nucleus in the circular orbit. Electrons will revolve around the nucleus in an elliptical orbit. Circular orbit is a special case of this. That is, major axis is equal to minor axis. Right. So, here when you consider the Sommerfeld model, the complex spectra of many electron systems could not be explained. You will all study about this Sommerfeld theory. What is complex spectra? What are many electron systems? All these in atomic physics. Here just a glance about these theories. So, in order to explain the complex spectra of many electron systems, vector atom model is proposed. Vector atom model is mainly dependent on two features. One is spatial quantization. Second one is electron spin. electron spin. So, what is this spatial quantization? Just a very brief discussion. See, electrons are revolving around the nucleus. Now, the momentum associated with the revolving electron is nothing but angular momentum. So, when this is subjected to external static magnetic field, B, the angular momentum vector L start to revolve round the direction of the magnetic field, and it creates an additional energy state. So that means, according to this model, right, as angular momentum vector started to rotate round the direction of the magnetic field, an additional energy level is created. But different electrons whose angular momenta vector are inclined at different angles. So, when the electron which is present here, when you supply the energy, it will get excited to this additional energy state. During the downward transition, it will emit the light. But the question arises, if there are n electrons, if there are n number of inclinations by the angular momentum vector, then can we get n number of spectral lines? Answer is no. As you know, in Zeeman effect experiment, single spectral line is split into two or more than two or three spectral lines. That means n number or infinite number of spectral lines are not observed. Therefore, the orientation of angular momentum vector and hence the creation of additional energy levels also restricted. They are in definite number. So that means electron orbits are quantized in space. N number of orientations are not possible. That is the concept we can discuss under spatial quantization. And electron spin. This concept is introduced in order to explain the observations in Stern-Gerlach experiment. That one you will study in atomic physics. So these are the two features of a vector atom model.